In this section of the course, we'll be covering algebraic expressions. In particular, in the first few lessons, in the first video, I'll go through the preliminary knowledge that you need to have. Then we'll cover index laws. After that, we'll look into expanding brackets, factorizing brackets, and factorizing harder version of quadratic equations in brackets. We look into negative and fractional indices and the rules that apply there. We'll look into surds and rationalizing denominators that involve surds. All right, let's have a go at it. On the first prior knowledge test, you need to simplify. I suggest you pause the video and have a go at these problems, and then unpause the video and have a look at my answers. If you don't know where these questions are, you can either download them from the resources that I've provided, or these are the prior knowledge tests at the beginning of each chapter. All right. Okay, I hope you've had a go at these questions by now. Let's go through the answers. I suggest you underline each of these terms are similar terms to each other and them together. The first part of the question, the first part, all powers match. So actually, this m square and n matches with this m square and n, and make sure you take the sign of the number with it, and yeah, to add up to 6m square n, and these m n square are different terms. So those terms that are underlined in a straight line add up to add up with each other. So you will end up with such an answer. So then in the next part, the power once again, like terms are those that have the same powers. So x squares here add up with each other, and then those terms with single power of x add up with each other, and then you have constants which are double underlining, those add up with each other. So then you'll end up with this expression here. For question 2, you have to use your prior knowledge of index laws. When we multiply, we add the powers. When we divide, we subtract the powers. And when there is a bracket between the powers, then we are multiplying the powers. So 2 and 3 multiply these 2 and this 3 multiply to give you 6. So in question 3, we're just expanding a bracket. So multiplying 3 by x and 3 by 4. So you should end up with such an expression. Part B, again, we expand the bracket. You end up with this expression: 6 times 2x and 6 times -5. Take care of the sign and make sure you do write the sign. For question 4a, we're looking for highest common factor, which we need to figure out when you factorize expressions. So if you have to factorize 24 and 16, you look out for highest common factor, which is 8, and then you would have factorized it. If there was a plus sign between 24 and 16, then you would have written 3 plus 2 with some of the terms probably, because you're missing those terms here. Well, I'm just making an example of the numerical ones here. So then for the next term, highest common factor of 6x and 8x squared is 2x. That's the term that you would write outside of the bracket. Here, the x and y, 1x power 1 and y power 1 is the common factor. For the question 5, if you had to simplify this fraction, 10 divided by 5 would give you 2, so you'd get 2x. Once again, we do some 10x, and this time 40 and 24, the highest number that divides both of them. So divide by 8. Right, so the challenge part is what I've put here. Which number is the higher? You can do this without a calculator. You think carefully. You can factorize an 11 out of 22 and 33. So you could write 5 to the power of 11 squared and write 3 to the power of 11. squared. Now we've got squares on both sides. If you can, if you think about it, you can take the square root of both sides of this inequality. We want to know whether it's this way or this way. We're not sure about it. But now it's clear that 5 to the power 11 is larger than 3 to the power of 11. There, there was a 3 here. So we cannot quite simplify 2 and 3. I'll swap the powers around. I write 5 is squared to the power of 11 and 3 to the power of 3 to the power of 11. So now you can take the 11th root, and taking the 11th root means that the powers of 11 cancel away, and then you can evaluate this 5 squared is 25 and 3 to the power of 3 is 27. Because 27 is bigger than 25, then raising both sides to the power of 11 would tell you that the 27 to the power of 11 gives you the larger answer. Alright, so that was a trick question regarding index laws. Let's look at the first exercise in the next video.